like to introduce Darrin Lowery, who will be presenting on, excuse me, I'm sorry, I'm not even close to the mic, coastal erosion and sea level impacts to archaeological resources in the Chesapeake Bay. Darrin, are you there?
I'm here.
Good morning, how are you?
Fine. I'm out looking at ice in Michigan, so I'm experiencing the effects of the landscape formerly under the Laurentide ice sheet.
I'm sorry for you. I'm down here in Florida, but that's just the way it is. But we're looking forward to your presentation, so it is up and you can begin whenever you're ready.
Okay, I'm going to put my stopwatch on so that I do not go over. I tend to go through slides pretty quickly. You'll note three letters, or the series of three letters behind me, PhD and then PNG. I'm going to explain what PNG is when I get to the end of this presentation. But basically, I grew up in the Chesapeake Bay on an island, and of course, for those that have experienced yesterday, they really know where the Chesapeake Bay is. But I'm going to focus on an area that was my backyard, and then we're going to zoom in. It's basically the mouth of the Chesapeake River. Today, if you look to the left of the slide, you'll see a shoal there. And this illustrates a process that I want to highlight today is coastal erosion and the vanished archaeological resources. In 1631, where that shoal is today, there was an island that was 1,400 acres. By 1675, it had been reduced down to about 900 acres. By 1848, less than half of that 900 acres persisted, about 438 acres. And you can see for the first time what that landscape looked like. There was upland, tilled fields, and marsh. By 1900, that island had been reduced to 91 acres. By 1938, it was down to about 13 acres. By 1946, the remnant, which is the tidal marsh, the topographic low area, had persisted because tidal marsh is more resistant to erosion. It was about 5 acres. By 1952, it was down to 2 acres. And by 1954, there was nothing left but a tidal flat. So basically, this island lost its battle with the Chesapeake Bay over a very short period of time. 1,400 acres disappeared in a period of less than 400 years. Now, the cautionary note that I want to illustrate here, this island teaches a lot, and I'm just as guilty of this. When you do pure bathymetric models, try to reconstruct landscapes, if you were trying to reconstruct a 1,400-acre island at the mouth of the Chesapeake River, circa 1631, you'd have to drop sea levels by about 4 meters. And that's the sea level about 1,000 BC or 3,000 years ago. So the point being is you wouldn't be able to reconstruct something 400 years ago using the current bathymetry. And also, you're using the current bathymetry. If you lowered sea levels by 2 meters, which is the sea level about 100 AD, you wouldn't even reconstruct the landscape circa 1848. So we know there was an island there in 1848. We got great maps. And this illustrates how pure bathymetric models for shoreline reconstructions give us false perceptions of shoreline margins. And therefore, what I'm trying to show here is that erosion has played a major role in our understanding of the Chesapeake and the landscapes that were available to people. And there were probably a lot more landscapes available to people not that long ago. And all of that sediment from this 1,400-acre island is now at the bottom of the channels. Why does this pertain to archaeology? Before there was any state historic preservation officer or even active attempt to record sites, between 1938 and 1948, over 16,500 artifact bifaces, mainly points and knives, were found on this low tidal marsh. And what do these artifacts really tell us? Well, first of all, they span the gamut from 13,000 all the way up to the time of John Smith. But what do they really tell us? They tell us of a process, and this is a process I've seen my entire life, that when you had that island, you had a vast upland with lots of archaeological sites. But as the island eroded, the archaeological sites vanished, but the tailings, i.e. the artifacts from these sites, transgressed with the shoreline. So in other words, as the shoreline retreated, the artifacts just continued along with it. Mainly the light fraction, not the heavier artifacts. But as the island reached its last gasp, and it was the topographic low, just nothing more than tidal marsh, All of those artifacts just washed up on the surface of that low tidal marsh. And to illustrate that process, I'll show you a modern analog to this. This is down in Dorchester County, Maryland, just south of the Chop Tank. You're looking out towards the bay. That's Barren Island. And you can see the oyster shells in the foreground. Those oyster shells are the secondary deposits from an archaeological site. That archaeological site is drowned. This is a late woodland site. You can see it drowned on the left, and you can see it at extreme low tide on the right. And you can see diagnostic projectile points. There's pottery and other things. We've dated it. It's around 856 Cal AD. So there is a drowned landscape there that people had access to, or at least threw their garbage on. But more importantly, you look at the near shore, and you can see the drowned midden. You can see the actively eroding swash and berm area. But more importantly, you can see the overwash debris. This midden, even though it's being destroyed by wave energy, is migrating as the shoreline retreats. This is a process I've seen time and time again as a kid in my backyard. To illustrate that, there's an energy component here. If you look between B and C, you'll see the firecrack rock and other heavy artifacts. If you go to D, which is the area where the berm is, you'll find the light fraction, mainly ceramics and flakes and other debris. Why is this important? And I'm going to bring this in because actually I see Tom Cronin's listed on here. There is a process that I've seen at this site that may be important that indirectly relates to archaeology. First of all, offshore from this site, there are living oysters. There's a few of them, and they get incorporated with the modern midden. So as a storm comes along, the wave energy lifts up a live oyster and carries it up on that berm. And as the oyster dies, its oyster shell or its shell container gets intermixed with the old shell, and they look pretty much the same. However, there's about a 12 to 1300 year discrepancy between their age. So modern contaminants get added to these things. This is important because there were two cores in the bay, and Dr. Cronin was involved in these, but there are some kind of indicators. There's two cores at 901 centimeters in this one core. They had two bivalves, and their age difference is about 2,800 years. And in another core, they had two bivalves in the same depth, and their age difference is about 2,000 years. And what I question here is maybe what you're seeing is overwash events, just like you see in the modern situation. And maybe those older shells, like the ones with highlighted with the yellow stars, actually are redeposited midden debris. So that requires a lot of investigation. So what are the clues and indications that prehistoric archaeological sites once existed in the areas now covered by the waters of the Chesapeake Bay? I happened to be privileged to work on a clam dredge when I was in college. And these things are great sieves. They excavate the bottom and they sieve the sediments. And you find artifacts like the one in the lower left here, found by fishermen in the Chesapeake Bay. This is an example of material found by Mr. Gus Jones during the single season in the Chop Tank River. But let's go back to Sharp's Island. Sharp's Island, we know existed. So in 1978, clammers hit that island and they began to excavate the bottom. And they found some of these artifacts. These artifacts have a different story to tell. A and B were clearly on that island. They've been tumbled, abraded. They've been subjected to acid sulfate geochemistry. However, C is not, and C is farther offshore. It's pristine, sharp. It is unpatinated and has never been rolled. And you go even farther out and you find other artifacts that don't seem to be tumbled and rolled. The point being is, even though Sharp's Island eroded away and it's a scoured landscape, to the leeward protected side, there may be intact resources. To show you the range of resources, these are some of the Paleo-Indian points that have been found by clammers. And I caution you here, the distribution of these things are highly biased by the laws of Maryland. You can only clam in certain areas. So in other words, when you see the big blanks, it doesn't mean that there aren't sites there. It's just that you legally can't go there. Let's go to the Archaic period. You got everything from the early Holocene all the way to the terminal Archaic. But I'm going to focus on the preservation of some of these sites. We're going to go to a site up on the Chester River that produced a lot of stuff. This is Nichols Point. This assemblage to the right here was found by a guy named David Haas in a single month in April of 1990. Gives you an idea of the immensity of stuff there. Let's go a little bit deeper. There are two types of clam rigs, those that can dig and excavate in shallow water and deep water. I happen to be on one that can work in deep water. So in this deep water situation, we found evidence of a cemetery. How do we know that? We have a human skull. But more importantly, you can see a hafted knife and an antler handle. There's projectile points to the right. There are spear thrower weights or banner stones. Matter of fact, they look like stone outboard propellers with no pitch. There's one to the right here that's been modified like an ulu. There's stone gouges, bone gouges, and you can see the tools that were used to sharpen these things. This is the assemblage I was on the boat that we found. We also found bola stones like you find in Florida. In an adjacent boat, an individual who was not familiar with archaeology amassed this stuff. This came up as a single pile, probably as a cache. He also found this banner stone and this gouge here, which is fairly large. The point being is we don't know what other things he didn't pick up. And that's what happens. Things get lost because they're not familiar with them. Go to the shallower deposits, much further in, close to shore, 8 to 10 feet of water, and you find terminal archaic stuff. This stuff is 3,800 to 3,200 years old. So the point being is you have a landscape that's drowned. In the deeper water, you have older stuff, and in the shallow water, you have younger stuff. And if you correlate that with sea level, when those folks were burying their dead 7,000 years ago, they were way in the upland. And then by 3,800, 3,200 years ago, this landscape was drowned. So in the Chesapeake Bay, there's a vast record that can tell us a variety of things. Just to show you preservation, this is woodland period stuff. There's tons and tons of woodland period stuff. These are only the projectile points per se, and the lithic artifacts, but you can see a hafted trianguloid end scraper still in its antler haft. And more importantly, that harpoon head is made of wood, not of bone. And there's a whelk-shell masket. So in these anaerobic, still areas, you can get some amazing preservation of archaeological deposits. And this shows the gamut of woodland period stuff, everything from about 2,500 all the way up to the time of John Smith that clammers have found. The most common artifacts are groundstone axes and pestles and big heavy basaltic things that are been made. Well, let me zoom back. Prehistoric ceramic vessel fragments are found virtually every day. I worked on one for 4 years. Every day we found ceramic vessel fragments. However, clammers, the fishermen, only recognize the complete vessels or those things with decorations like the one to the right or like those shown here. And that map that shows the woodland period stuff, I didn't even include the ceramics in that tally because there's just so much of it. The most contentious artifact ever found by fishermen was exhumed by Captain Thurston Shaw on the vessel Sinmar, which was owned by Liston Shackelford. When this came to my attention, I just viewed it as like, this is normal. However, from the outside world, a lot of folks thought this was abnormal. This is the captain's log in the upper portion. You'll see the thing number 52, bones and point, and then there's some sort of weird reconstruction of what it may have looked like. But it's about 242 feet of water or thereabouts. 38 to 40 fathoms is what he was recorded. The vessel in the upper right was a small vessel compared to modern ones today. It just essentially scrapes the surface. The Sinmar discovery was not well received by the scholarly community, mainly because they're not familiar with drowned finds. So salvos were fired. The negative feelings clearly illustrate the misunderstandings by academicians with respect to fisheries technologies, reporting, and the frequency of chance discoveries. This article came out. They said that it was never recorded as hang. We made up the vessel, basically, and it got into a scholarly article. But it's a sad commentary about the peer review process because it illustrates, you know, these issues could have been rectified with a simple phone call, but I don't think these folks really had that intention. But anyhow, that being said, I told the powers that be, well, I'm going to show them what they do, what a fisherman does with the fish when you catch it. And I think everybody in the crowd probably knows what you do after you catch a fish that you're going to eat. You usually gut them. So anyhow, the point being is, even other scholars, this is Vance Holliday, he wrote the Sinmar finds, never had any context, they're not even ordinary, they barely rise to the level of hearsay. And spending time and money is a waste of efforts. However, in 2013, there's Dennis Stanford, John Madsen, Jack Stallings, and Peggy took this picture. You can see going out there where the landmarks were, there's a Madsen's reconstruction of what the bottom looks like. You can see the offset, the upper right-hand corner of this image shows John O'Shea's reconstruction. He was able to really get more detail. And you can see where that mastodon was. It was in a shallow depression or a ponded area. Now, whether the biface is associated with the mastodon, the only way you can rectify that is go look. However, what is down there on the bottom? I guess we'll never know because the Sinmar data are not extraordinary. They aren't even ordinary. They barely rise above the level of hearsay. In my community of living in the coastal environment, I never doubted the Sinmar find. But if you grew up in Kansas, you probably are unfamiliar with those finds. Can we learn anything from rapidly eroding landscapes containing archaeological sites? You'll see this reconstruction. You have Sharps Island there in this one map on the left. However, we're going to focus on James's Island. James's Island's a big landscape, and I've watched it melt away into the Chesapeake Bay. There were sites there, but we're going to show you what the rate of erosion is. On the left-hand side, you can see about 7 years. There's the northern end of James Island all the way down to the nothing left but the tidal marsh. Always in every situation, last to go is the topographically low landscape, the tidal marsh. You can see on the right here, a period of 4 months, going, gone. If you adopt a carpe diem methodology, seize the day, when you see something in the bank, react accordingly, you can find stuff and you can salvage something. Who has legal jurisdictional mandates with respect to eroding resources along our archaeological resources along eroding shorelines? It's different from state to state. In Virginia, Virginia is a mean low tide state. And that's what you're seeing in the lower left-hand corner. Maryland's a mean high tide state. Maryland has another law that says we regulate any disturbance within 300 feet of the mean high tide. Well, last I checked, this is probably the biggest disturbing entity in the Chesapeake Bay along its 11,000 linear miles of coastline. And the loss of archaeological sites along the exposed margins of the Chesapeake Bay is, and will continue to be immense. The recently retired Maryland State archaeologist and retired SHPO once told me, you cannot learn a thing from eroding archaeological sites. If a tree falls in a forest and no one's around to hear it, does it make a sound? From their perspective, you're not even around to hear it, so it's not going to make a sound. However, I am willing to listen to some of the falling trees, and as such, I will prove their assertions wrong. We're going to go back up to my home turf on a little island called Parsons Island, and you can see it in 1969, and you can see the same view, same perspective, same location in 2016. So you get an idea of the magnitude of loss. If you look at it in Google Earth, you can kind of reconstruct it here. And in 1992, you get an idea of the landscape. By 2019, it's clearly heavily eroded, and you'll note that the erosion is asymmetric. It's not uncommon. The northwest side of the island is very protected. As a result, it's not retreating the most. The southwest side is the most exposed, so it's retreating the greatest. We started investigating this eroding island in 2013. Why? We were interested in the late Pleistocene upland stratigraphy. We had left a site in the same watershed and had questions. So we began looking at this landscape with a better understanding, and hopefully we can develop a higher resolution understanding of what this landscape was during the LGM and post-LGM, and in some cases pre-LGM. However, within a month, we started finding a few artifacts in this buried paleosaw. We had charcoal that we could date, so we did that. And these are some of the artifacts. You can see these bipointed bifaces here. Some are big, some are small. Some show aeolian polish as a byproduct of being subjected to a surface for some unknown period of time, being pelted by silt and sand. Some of these bifaces were intentionally smashed, and the fragments were used like burins or gravers. You can see lancelet points to the left, and you can see some of these bipointed bifaces were probably converted to lancelet points as a byproduct of them being broken. You also have blades, as many show utilization. You have cores, polyhedral blade cores. Again, look at the top of that platform area of that core. That's intense aeolian polish. Note the bottom of it does not show that. Here's another core. Top of it shows aeolian polish. Bottom of it doesn't. Presumably this artifact or these artifacts were exposed to the surface. The bottom portion was not. They were pelted by silt and sand over a period of time of unknown duration. There are other cores. This is a big biface that they probably were going to break, but you can see the reduction here of detaching blades. This sort of blade reduction from a snapped biface or a big biface or what they call a gigantolith is reminiscent of some from Kostinki. These are some shouldered blades that we found there on the left. We have snap blades that they're making tools out of and utilizing. The predominant artifact from this site is debitage, but very small debitage, little teeny tiny things. And with a few bigger pieces. They're not making things there. They're just retooling and resharpening. In February 23rd of 2017, we sieved the bottom in front of the site, and we found 63 little teeny tiny flakes that I could probably hold in one hand. So that the bulk of the artifacts are found in that single day. Let me go back. And a month later, the Smithsonian went out there. That's Peggy Jodrey on the left, but the right-hand side of the pit, and Bruce Bradley on the other side, and it excavated inland. I plotted these units. You can see that on the right, and that it's important because just because you excavate there and you leave doesn't mean the shoreline stops eroding, and I'll show you that in a minute. This is the only in situ artifact that they found, was a little teeny tiny quartz flake, very common there, and they found some charcoal, and I'll show you what the date on that one is in a minute. Over a 7-year period, we plotted everything, flakes, artifacts, whatever else, but you can see the 2017 shoreline, where those arrows point out into the sand and where the Smithsonian units were, and then you can see the 2019 shoreline. It's retreated several meters. The point being is the shoreline continues to erode. What we learned there over a 7-year period is really storm activity is not your greatest foe. It's ice. Ice in the bay during the winter months causes the banks to be undercut by slabs of flowing ice or slamming in. They're like battering rams. And more importantly, the bank will freeze and then it thaws and it looks like something you'd see in Siberia, like solar fluxion. However, we did some paleo-environmental reconstructions, which I won't highlight much of those in this presentation. But we looked at plant macros, that is carbon, to identify the trees. We looked at phytoliths, and we looked at pollen to reconstruct what this landscape was like. And there are buried landscapes that extend back about 40,000 years to the south of where the site locality is. This is probably what Parsons Isle looked like when it was occupied by humans, maybe with a little bit more grass. It was an aeolian landscape that had been stabilized. And there were some interdunal ponds. However, after the folks abandoned that landscape, the dunes reactivated, or the landscape got pelted by loess too as well. So that's when a lot of those artifacts got polished. So when was the site occupied by humans? We've done lots and lots of geoarchaeology out there and geochronological data. These are the dates, and we have about 15 more dates that I include in here recently, but more importantly, they're consistent. The archaeological level, which is about 2 meters beneath the ground surface, ranges between 20,700 and 23,000. Now remember, this is environmental charcoal, not cultural charcoal. However, if you look at the overlying OSL dates, they kind of are consistent. More importantly, we just got this date in the fall for our younger driest loess on spec. We have a date that calibrates to 12,781 plus or minus 28 years BP. That's at 2 sigma. So that's really brackets our YD loess and the onset. More importantly, when you look at these 2 surfaces that are stacked, we have the archaeological surface, the 4AB1, and then we have the other surface beneath it, the 4AB2. And you can see we actually identified the charcoal. In 2020, we did testing there during the COVID shutdown. We excavated 4 units. We found some artifacts in situ. You can see that on the right. As is the case, you leave, you go, and this popped out. Never seen anything like this before. A flat slab of rock mounted on 2 or 3 other pebbles or rocks. One of those rocks shows abrasion. You can see that. This past summer, Mike Waters, Texas A&M, came out because I realized that there are very little interest in the Middle Atlantic institutions in prehistory. They came out, did some work, preliminary work. They had to cut it off early, but they found a few artifacts. And they got a lot of samples to run dates. And as is the case, they left. And another artifact, this is a hammerstone sticking in the bank profile. So what other data seem to support the possibility of humans south of the North American ice sheets between 23 and 20,000 years ago? By the way, there's a link at the bottom. If you want a copy of the final monograph, feel free to link on it. So what other data do we have? Not surprisingly, or actually surprisingly, after I finished that monograph, within a few months, this article came out and it talks about human footprints at White Sands, New Mexico, data between 23 and 21,000 years ago. And note that Vance Holliday, the guy who said there's no reason to investigate Sinmar, is one of the co-authors. Another article that recently came out focused on the patrilineal side of the genetic record for the Native Americans. And these 2 groups are ones you want to focus on. And basically those 2 groups, you can see recognized as being present in the Americas between 22 and 24,000 years ago. Isn't that interesting? So what other data do we have that the pathway between Siberia and North America, the lower 48, was not necessarily impassable? Folks working at Natural Trap Cave found the Beringian wolf. It first appears in their deposits around 25,800 years ago. A lot of people think the Laurentide and the Corollaran reached their maximum at the same time. Not so. The Laurentide reached its maximum about 5,000 years before the Corollaran. The Corollaran didn't reach its maximum until about 16. But the point being is they found this animal and they say the only way it could have gotten there is if it went through that corridor, and more importantly, the corridor was passable at certain intervals. So therefore, if a four-legged predator can make it, I'm pretty sure a two-legged predator could make it as well. Other data, and this is sort of serendipitous. Why would you go to the Chesapeake? At Malta, which is 24,000-year-old human burial, they find ivory carvings of waterfowl. They don't find mammoths or woolly rhinoceros. They find waterfowl. Things that look like tundra swan. More importantly, the U.S. Fish and Wildlife Service put tracking devices on tundra swan, and you can see that those north of the Brooks Range end up going to the Chesapeake, and those in the Bering Sea and the Aleutians go to California, and you can see white sands on one side, and you can see the Chesapeake sites on the other. Summary: shoreline erosion and late Pleistocene Holocene sea level rise played major roles in understanding the Chesapeake Bay region. Coast erosion is dominant natural variable during periods of relatively stable and slow sea level rise. An archaeological site inundation or preservation is more likely to occur in protected areas or during periods of rapid sea level rise. And there are various jurisdictional responsibilities these states have. Some should embrace a carpe diem methodology. And drowning, attacked, and displaced prehistoric archaeological remains are common throughout the Chesapeake Bay region. They're not rare, they're everywhere. Finally, after 28 years, I've concluded that virtually all of the academics and agency heads in the Middle-Atlantic do not really care to listen about the archaeological record. Many of these folks do have PhDs, but they lack the most important P in the archaeological investigation equation, and that P stands for passion. Also, human interests greatly affect the observation and perceptions of the region's past. There are no academic or state agency interests in reinvestigating Middle Atlantic prehistory. It's contact period and later. And finally, and most importantly, there have been many folks who have aided and assisted with the previous outline research. I could give a 20-minute presentation just showing their names. So that's all I have to say about that. Any questions?
Darrin, can you hear me?
Hey.
Yeah, sure can.
I want those slides of those paleosols for my class.
Oh, okay, sure, I can send you. Actually, there's a hyperlink. You can download it and you can cut and paste till the cows come home.
I have a question. Where did you get that bee? I'm not used to seeing bees in coastal paleosols.
You know, the B horizons, I mean, basically they're welded. The AB, the 4AB is basically, it's a buried indication, but there are cambic, depending, to the south on the Parsons Island, there are cambic horizons. They're, as the shoreline erodes, it's becoming more and more argillic because you're dealing with, there was probably 20,000 years of stability before you end up with that 20,000 year surface being deposited and forming on top. More importantly, those two stacked A horizons indirectly tell you that there isn't that much bioturbation, at least in the Middle Atlantic at that time. And it may be because of its proximity to the Laurentide ice sheet. Laurentide ice sheet is only about 250 kilometers north. Normally you would expect churned landscapes, but we have over 15 more dates now, and you get the same pattern, boom, boom, boom. I've got a whole bunch of OSL dates too that I didn't put in that as well. So anyhow, did that answer your question, or did I effectively avoid?
It just whetted my appetite, so we'll talk further.
Okay, have your people contact my people.
I certainly will. And oh, by the way, down in the South Atlantic, we do care.
Okay, well, here in the Middle Atlantic, if it's 17th century, 18th century, and African diasporas, that's what's right. If we had had a slave quarters washing out at Parsons Island, they'd have been all over it.
I got you.
So I see Tom Cronin said great talk. So any other questions?
Yeah, here's one. I'm Robert Constant, just a local resident here who's very interested in archaeology. And it looks like on that slide you showed for the trajectories from Beringia and the big mass of ice, it looked like that if you just sort of were migrating down the edge of the ice and just kept going, you ended up in the Chesapeake Bay. Is that right?
That's right. And believe it or not, when you look at the geology between the Laurentide and Fort Laramie, it's exactly the same as what we have as a reconstruction there. So it's a familiar landscape. It's an aeolian landscape with interdunal ponds. You have grassland and meadows. More importantly, and I failed to mention this, when you think about why would you follow tundra swamp, they're kind of like the canary in a coal mine. You know, my father ate tundra swamp when he was young. He was, born back in the early 20th century. And he said the best ones to eat were the young ones because they tasted less fishy and they were tender. But the point being is, imagine yourself in Alaska during the LGM and you see all these swans leaving with their new breed and they're heading south towards these big blocks of ice. What's that going to tell you? It's going to tell you there's something warm south of those ice sheets. If you follow a herd of caribou, they might lead you somewhere else. A herd of bison might lead you over a cliff. But I can tell you one thing, those birds are going to tell you something.
Yeah, right. Very interesting.
Any other questions in our present audience? Any additional questions online, Jill? Well, again, thank you, Darrin. We appreciate your participation.
Okay, then. Sorry I went over.
Oh.